Hey, good morning, everyone. It's 9:01. We'll just wait. Looks like there's some more people
Good
joining.
morning.
There we go. All right, so welcome back, everyone. Hope you had a good spring break. I know I did, and then yesterday I started feeling under the weather, so I'm feeling better today, but let's see how this goes for me. Any questions before I begin? Reminding us what we were doing because it's been so long. Okay, today we're going to continue doing graphs of rational functions. That's what we had talked about last time. And then on Wednesday, we're going to cover polynomial and rational inequalities. And then the homework assignment for today is going to be given at the end of class. And then you do not have to do anything online for homework for tonight's stuff. I'm going to give you the review for the exam, and I want that to be your homework for tonight. So exam 2 is a week from today, and when you look at the review, you'll get an idea of what will be on that exam. So that's pretty much it. Let's get into rational functions. So I do realize it's been like roughly almost 2 weeks since we've talked about anything. So let me remind you what we were doing. We were talking about rational functions. We defined a rational function to be a polynomial divided by a polynomial. And I gave you 3 examples of rational functions. And we actually went through the steps of graphing this one right here. And I asked you to maybe try those 2 on your own. If you did, great. If you didn't, don't worry about it. I'm actually going to do those today. And then here are the steps for graphing a rational function. There were 7 steps. So let's go ahead and just pick up with this first example here and get right into it. We're going to take this rational function, we're going to graph it. So here's the rational function. Let me go grab those steps again. Let's see here. All right, so I'm going to put the steps here. I'll make them a little smaller so they don't take up all this space. Okay, so first thing we want to do, we want to make sure we're looking at a rational function. So we do recognize that we have a polynomial divided by another polynomial. And so the first step is to completely factor the numerator and denominator and then cancel any factors, remembering that if we do have any common factors that cancel, we're going to have a hole in the graph at that point. So when you look at this rational function, there's nothing you can do in the numerator. X plus 1 is just x plus 1. But the denominator can be factored as a difference of squares. So x plus 2 times x minus 2. And we look at this and we notice that there are no factors that can be canceled. There's no factor on top that is common to a factor on the bottom. So we have no holes, but step 1 is done, right? No holes. The next step, step 2. So step 1, we've got that done. There are no holes in this graph. Step 2 is we are going to find what we call vertical asymptotes. Those are those vertical barriers that would force our function up or down. And to find those, what we do is we set the denominator equal to 0. So since we've already factored the denominator as x plus 2 times x minus 2, all we have to do is set each of these factors equal to 0. And we get 2 solutions here, -2 and +2. So these are our 2 vertical asymptotes. And I'm just going to remind you that these are vertical. When we draw these on our graph, they're vertical dotted lines, right? That's what those are, these vertical dotted lines. And when our graph gets to those, our graph can't cross through them. The graph has to go up or down when we get to that dotted line. Okay, third step is to find the x-intercepts. And to do that, we set the numerator equal to 0 So we set the top equal to 0. That's just x is -1. So this is actually a point on the x-axis, right? And it's important for us to understand that at -1, we will have a point on the x-axis. That's part of our graph. This is the only point that can ever be on the x-axis. We cannot have any other x-intercepts. This is the only one, all right? Okay, fourth step. No questions up to this point? We're okay? I realize it's been a while. Fourth step is the horizontal asymptote. And this was I think the most challenging part, because there's 3 different cases that we can have. What we want to do is we look at the degree of the numerator and denominator separately. And I said, let's call the degree of the numerator, which in this case is 1, right? That would be our n, the degree of the numerator. And then 2 would be the degree of the denominator. That we'll call that d. What we do is we compare them and we say, you know, is the numerator less than denominator? Is the numerator greater than denominator? Or are they the same? In this case, the degree of the numerator is smaller than the denominator, right? So we have this case, 1 is less than 2, right? So we are in this case right here, which means the x-axis is our horizontal asymptote. So for our horizontal asymptote, we have that the x-axis is the horizontal asymptote. Now, what does this represent on our graph? This is a horizontal dotted line. Okay, but you only draw this at the edges, only at the ends of the graph. And the thing about this horizontal asymptote, it acts like, I told you all last time, it acts like a magnet, all right? And it kind of pulls our graph towards it at the ends of the function only. Okay, that's it. We've got the first 4 things. Fifth step is we want to try and start putting our picture together. So we want to start drawing this now. So let me get a basic graph going here. Okay, so let me start with the first thing that we had. We had 2 vertical asymptotes, one at 2 and one at -2. So I'm going to draw these. Here's 1, here's 2. I'm going to draw a vertical dotted line at 2, and at -2, I'm going to draw a vertical dotted line as well. Now remember, that dotted line is not technically part of the graph. It's just to help us graph. And then now I'm going to start drawing the graph. I have an x-intercept at -1. So now I'm going to do my graph in blue. At -1, I have a blue dot there. That is an x-intercept on my graph. And then I have a horizontal asymptote of the x-axis. So now I'm going to draw a horizontal dotted line, but only at the edges of the graph. So over here on the right-hand side, horizontal line coming off of the x-axis, this red dotted line, that's my horizontal. Notice, again, I did not draw it all the way through, only at the edges. Okay, that's it. I've got all the basic parts of the graph drawn. Now what I need is to move on to step 6, which is to pick some test points. And what I told y'all was to figure out how many test points you need, you look at how many verticals you have and how many x-intercepts I have. So I have 2 verticals. I have 1 x-intercept that gives me three different values there, -2, -2, and -1. Since I have 3 verticals and x-intercepts together, that means I'm going to have four test points, okay? So to find them, I always start at the left. I look at the first thing I have here. I have this vertical here at -2. I need to pick any point I want to the left of -2. So I'm going to pick -3. And I like to use a little X there, not a dot, right? Because if you put a dot, you might think it's part of your graph. So that's a test point I'm going to pick. Then I have to pick a test point between these two, between this vertical and this x-intercept. That's going to kind of suck because there's not a nice number between there. So I'm going to pick, how about negative 1.5? And then I need any point between this x-intercept and that vertical. So I like 0. 0 is a good one. I need one more test point, and that'll be anything to the right of this vertical, which is 3. Are there any questions on the picking of the points and like where you're picking them from and what you're trying to achieve? Y'all understand or no? We're good? Okay, thank you, Javier. Thank you, Henry. Okay, so what do we do with those? Well, we're going to take these points and we're going to plug them into the original function. And what we're looking for is whether or not we get a positive or a negative number out. That's pretty much all we need to know. Does it spit out a number that's going to be above the x-axis or below? So unfortunately, I have to figure out what f of negative 3 is, what f of negative 1.5 is, and what f of 0 is, and what f of 3 is. And I'm plugging those into my original function, which I'm going to come back up here and copy it. This was my original function. And what I like to do is I like to plug these into the factored version, because the factored version, if I plug it in there, it's very easy for me to figure out whether or not I get a positive or negative number out. Okay, so just think about this. If I plug in negative 3, imagine what happens if I plug in negative 3 to the top. Negative 3 plus 1 would be negative 2, right? I don't even care that it's negative 2. I just care that it's negative. I get a negative on top. On the bottom, I get, let's see, if I plug in negative 3 here, negative 3 plus 2 is negative 1. That gives me another negative number. And then I'm going to multiply that times, if I plug negative 3 in here, negative 3 take away 2 is negative 5. So that's another negative number. So I get all negative numbers there. And now if I think about this on the bottom, if I multiply those two negatives together, I will get a positive. And then if I do a negative divided by a positive, I will get a negative. Does that make sense? That I actually don't care what the value is. I just care that my point is going to be below the x-axis. So that means when I go to negative 3, right here, when I go to negative 3, I'm going to put a point below the x-axis anywhere I want. Okay, it doesn't really matter. I'm just going to throw it right here. Okay, there's my point. Right, we got to do the same thing for negative 1.5. So let's try that. Move these down here. Okay, so for negative 1.5, imagine plugging that in again over here. Let me erase all this stuff here. Okay, so if I plug in negative 1.5 into the top, negative 1.5 plus 1 would still be negative, right? And then negative 1.5 plugged in here, negative 1.5 plus 2 should give me a positive number. And then negative 1.5 into there, that should still be negative. So now when you do this, you have a negative on top. On the bottom, you're multiplying a positive and negative together. That should still be negative. And then a negative divided by negative is positive. So that means when you plug in negative 1.5, you should get a point above the x-axis. So I'm going to go put that point at negative 1.5, just anywhere I want. I'm going to put a dot. Is this making sense? Are there any questions? Good. Okay. All right, let's plug in 0. If we plug in 0, let's follow the same procedure. Plug in 0 to the top and bottom. If I plug 0 in here, 0 plus 1 is 1 on top, so I get a positive on top. And then 0 plus 2 is 2, that's positive. And then 0 take away 2 is negative. On the top, I have a positive. On the bottom, I have a negative, because a positive times a negative is negative. And then when you divide a positive by a negative, you still stay negative. So that means when I'm at 0, I put a point below the x-axis, anywhere I want. I'm going to put it right here. And then finally, you plug in 3, right? So when you plug in 3, you should get on top a positive, and on the bottom, they'll both be positive. And that means that a positive over a positive will be positive still. I went through that one a little faster, but if you understand the idea, it's pretty easy. Just plug the number in. So over at 3, I'm going to put a point above the x-axis. All right, that's it. I should have everything I need now to draw the picture. So when I draw this, I have to remember that that dotted line at the edges acts like a magnet, pulls my function towards it. The vertical dotted lines are barriers that force my graph up or down. And if I have any x-intercepts, I have to actually get to them. So I'm going to start at the very left point, which means I'm going to start here at that point right there, and I'm going to start drawing my graph. Okay, so to the left, I see the dotted line over there. I need to get pulled towards it like that. Get closer and closer to it without it actually ever touching it. And then as I try and draw to the right, I have the vertical barrier in my way. And that's going to force my graph to either go up or down. All right, it's up or down. In this case, it has to be down. It cannot be up. And the reason it can't be up is because if you turn this thing up like this, you will have created an x-intercept that does not exist. Okay, you just made something, you just made an x-intercept appear when the only x-intercept we should have is the one at -1. Hold on just a second. Okay, so the only x-intercept we should have is right here, -1. And so you would create a new one, which isn't good. So it can't go up, which means it has to go down. So it goes like this. I can extend that dotted line a little bit. There we go. Okay, so that's what the left side of this graph looks like. Now I have to pick up my pencil and go to the next point that I have, which is here. And the same idea. If I go out to the left, I either am going to go down or I'm going to go up. Well, again, if I go down, I create an x-intercept. So it can't be that. So it's got to be the one that goes up. So it's going to go and turn up like this. And then as I draw to the right, I'm going to just connect these 3 dots together. And when I get here, if I keep moving to the right, again, this vertical asymptote is going to force me up or down. I can't go up because I'll create an x-intercept, so I must go down. Then I pick up my pencil, I go to the next point to the left. Again, I have to go up, right? Can't go down. As I go to the right, I will get pulled towards the magnet and flatten out. There it is. Questions? That took us what, like 20 minutes? So you just got to take your time through this. Remember, when you're done and you look at your picture, it needs to pass the vertical line test. So it needs to be a function. So when you draw vertical lines, you should not hit the graph more than one time ever. Okay, so you can see very clearly that I have a function here, right? It passes the vertical line test. So just make sure you have that. I've seen students do weird stuff before where they start curling things back around and do, like, I don't know, they'll just do weird stuff sometimes. So just remember that it has to still be a function at the end. Any questions?
I had a quick question, Professor. And you said, why do we need 4 test points?
That's just the rule of thumb. It's not always 4. It's always one more than the total number of vertical asymptotes and x-intercepts you'd have together. So since we had 2 verticals and 1 x-intercept, that's total of 3, that tells me in order to draw this, I'm going to need 4 test points. Got it? Okay. Let's see. I think I put it here. Yeah, I put it in the notes. You should always have one more test point than the number of vertical asymptotes and x-intercepts combined. You could have more test points, but that's all you need in order to draw it.
And that's why we did the -3 and the 3, right? With the x and the 0.
Yes.
Okay.
I needed, you always need something on both edges to kind of give you an idea if you're above or below. And then you need something in between everything in the middle. Now, let me remind you again, you know, this whole idea of getting a positive or negative, people are going to have different looking graphs because if someone, you know, I put this dot at -3, we said we got a negative number. Somebody else could have put their point up here, or they could put it down here, or here, or here, anywhere, right? And so their graph might look a little bit different than mine, right? But that's okay. That's okay. As long as our left behavior and what happens at that vertical asymptote is the same, that's all that matters. So we're not too concerned about the up and down. Yes.
So those test points could be any number that we want. Like it could have been -4, -5, and then the
That's right.
placement below that number could be anywhere.
Yeah.
Like these
exactly.
examples that you were given.
Exactly. So
Okay.
somebody else could have said, oh, I'm going to test -5 instead. But here's the thing I can tell you, if you do that, you're going to get a negative answer. Like when you plug in -5, you will get negative. So you put your point here, and I don't know, maybe your graph looks like this instead of like mine, you know, but they'll be similar. If we go look at the original, like what the graph looks like on a computer, you know, here's what it looks like on a computer. X+1 divided by, oh, no, that didn't work. X+1 divided by x² - 4. So there's the graph. Let me see, x equals -2, x equals 2. I'm just putting these vertical asymptotes so you can see them here. Okay, so there's their graph. It's hard to fit this all on here, but let me see. I mean, ours is decent, right? I mean, we have the same x-intercept right there, right? At -1. To the left, it goes up. Here it goes down. We've got that right there. On the right-hand side, we plugged in 3, got a positive number, it goes up and then flattens out. That's what we've got there. And on this side, same thing, right? So we want that basic behavior illustrated in our graph. Okay. Let's take a look at the next one I want to do. Okay, and let me grab this again. Our steps, so we have them. All right. So first thing I'm going to do is factor everything. And I noticed that in the numerator, I can pull out an x first. I can pull a GCF out. In the denominator, I can't pull anything out. It's just x+7. But then I also recognize that x² - 4 is a difference of squares. So this factors again, x+2 times x - 2. And we also had that x out front still. So this is my factored form. Right, I'm completely factored there. I'm checking for holes. I'm making sure I don't have any common factors, and I do not, right? You can look at that x+7 as its own factor. Nothing cancels out. So the first step, I'm done here, no holes. No holes, right? So why don't I do this? Why don't I give you 5 minutes tops? See if you can do steps 2, 3, 4, and 5. Let's see how far you can get with 2, 3, 4, and 5. So when you get to test points, don't do your test points yet. Just see if you can get at least what the vertical is, if there's verticals, x-intercepts, horizontal asymptote, and try and draw it all on the graph. Let's take 5 minutes, see how you do with that. I just launched a poll. All I want to know is when you're done with the 5 steps. Okay, let me know. And we've got 3 students done so far. Okay. I think that's enough of you that are done at this point. All right, so real quick, vertical asymptote, we set the denominator equal to 0, x plus 7 equals 0, we get -7, so we have one vertical asymptote. The x-intercepts, we set the numerator equal to 0, so we have to take this factored form of the numerator, set each of the factors equal to 0, we get 3 solutions, 0, -2, and 2. And then we look for a horizontal asymptote, so we compare the degree of the numerator, which is 3, to the degree of the denominator, which is 1. And that gives us case 2 here. Case 2 tells us we have no horizontal asymptotes whenever the degree of the numerator is bigger than the denominator, which means that the left side is going to go up or down. We don't know yet. And then the right side is going to go up or down, but we don't know which one. It's just not going to ever flatten out. Okay, that we know. It's not going to flatten to something. There's no magnet. So now we put all this information on a graph. All right, so for my graph, let me put this right here. Whoa, that worked out. Okay, so here's my information. First, I have a vertical asymptote at -7. So I'm going to go over here to, like, I don't know, I'm going to say that's -7 there. I have vertical asymptote here. All right. Then I have x-intercepts at 0, at 2, and at -2. Okay, those 3 dots are part of my graph. I have no horizontal asymptote, so I'm not going to draw any horizontal dotted lines. I'm just not going to do anything. I'm just going to remember that I don't have anything. All right. So I'm going to need how many test points then? 5, right? That sucks, but that's what we got to do. We got to do 5 because I've got 1 vertical and 3 x-intercepts. That's a total of 4, so I need 5 test points. Let's see, my first one, let me pick something to the left of -7. How about -9? Okay, I could do -10, I could do -8. I just have to do something to the left. Something between -2 and -7. Let's go with -4. Something between -2 and 0. Well, -1 is a good one. Something between 0 and 2. 1. And then anything to the right of 2, anything I want. So I'll go over here. I'll say that that's 4. So I need to figure out what happens when I plug -9 into my function, what happens when I plug in -4 to my function, what happens when I plug in -1 to my function, what happens when I plug in 1, and what happens when I plug in 4. I realize this is tedious. Students will sometimes ask me, like, is there an easier way to do this? And, you know, yeah, I mean, you just go to Desmos and type in the function, have it graph it for you. Other than that, though, really, this is the way we do it mechanically by hand, right? It's a procedure. So, and there's advantages and disadvantages to doing it this way. One of the disadvantages is that it's slow, okay, and you can make a lot of mistakes. But the advantage is sometimes the computer doesn't show you enough of the detail. You have to zoom in properly to see everything happening. Where our picture, it's going to be very clear to us exactly what's happening. You'll see, we'll compare our answer to theirs in a minute. Okay, so I need to go grab the function. I'm going to grab the function in just the factored form of the function right here. I'm going to slap it over here. And now I'm going to start asking myself what happens when I plug in -9. Okay, -9 in here. And when I say I'm plugging -9, I'm going to go first right here. -9 by itself is just -9. That's a negative number. Times, okay, -9 plus 2 is still negative. Times, now -9 take away 2 is -11. That's still negative. And then that's all over -9 plus 7, which is also negative. So everything's negative there. On the top, if you do a negative times a negative, the first 2 negatives gives you a positive. But then you hit it with another negative and it's going to stay negative on top. The bottom is negative, and a negative over negative is positive. So I know at -9, I have a dot anywhere I want above the x-axis. So I'm going to put it right there. Do y'all understand this part, the plugging in, what I'm doing with the signs? Like, look, you're completely free. I'm not telling you not to do this. You could take -9 and just plug it into this original function right here. Go ahead, I don't care. And you'll get an exact number. And that's fine, but it's going to take you longer. All right, it's going to just take you longer to do that than it's going to take me to figure out whether or not it's negative or positive. You'll have a more accurate point, but again, you're giving up time on that. So I say go with, is it positive, negative, negative? That's what I recommend. By the way, why can you not do the same idea here? Why can't you just be like for example, with -9? Let me take this down here so you know what I'm talking about. Why can't I just do, oh, okay, if I plug -9 there, -9 cubed is still negative. And then I say minus, and then if I do 4 times -9, that's still a negative number, right? Why can't I do it this way?
Isn't it because it's different powers?
Yeah, but think about this. If right now, what is this telling you about the top? You
You're not
have a
going to find a
negative
third
number
number.
minus a negative number, right? That's not enough for you to be able to tell me what the answer is. For example, if I tell you -4 minus -2, what's that answer? Is that positive or negative? Isn't this really -4 plus 2? Isn't that just -2, right? So yeah, the answer is negative, but watch. What if I do -4 minus -9? How about that? Well, that's -4 plus 9, right? That's +5. What I'm getting at is when you're adding or subtracting negatives and positives, that's not enough information for you to tell me whether or not the answer is positive or negative. The only way you can ever tell me if an answer is positive or negative is if you're multiplying, which is why I have to do this in the factored version only. Hope that makes sense. And it's easier. I mean, this is a little harder to do, so don't do this. In fact, I'm just going to erase it. I don't want it. I don't even want it there. Okay, so I'm not going to go through each of these, all right, because it's just going to take me too long, but I'll just tell you what the answers are. It's negative, then positive, then negative, then positive. Is that all right if I don't show it? Do you notice that it just switched every time? Like once I found the first one, do you see it just went from positive to negative, then positive, negative, then back to positive, right? And in the previous example, did it do the same thing? It was negative, positive, negative, positive, wasn't it? Right? So you start to say, well, wait a minute, then can't we just find the first one and then just switch all the others, right? Unfortunately, you cannot, okay? You have to check them because sometimes it doesn't do that. It looks like it does, but it doesn't. We're going to do an example where it doesn't, okay? All right, so let me do this. At -9, I put a dot above. At -4, I put a dot below. At -1, I put a dot above. At 1, I put a dot below. And at 4, I put a dot above. Questions? You okay? Time to draw. All right, I'm going to start here at the far left point right there. To the left, what must happen? Good. Dominic's saying up. Remember, we said it has no horizontal asymptote, right? No horizontal asymptote. So it doesn't flatten out, which meant it either goes up or down. It can't go down, right? See, because if it goes down, you just created an x-intercept. It can't go down. It has to go up. So it goes up to the left. I'll just do it like that. Now, to the right, as I start to draw to the right, I see a vertical barrier in my way, right? So the vertical barrier forces me up or down. In this case, which way? Up again, right? You can't turn down. If you go down, you're going to cross the x-axis. So it's got to go up again. So it almost looks like a little parabola in there. It's not truly a parabola, but that's kind of what it looks like over there. Weird, huh? And then we go to our next dot, which is this one right here. And to the left, vertical barrier forces me up or down. I can't go up because I'll cross the x-axis, which means I have to go down. So I'm gonna draw it like this. I'll extend this dotted line a little bit. And then look, you don't have any more verticals in your way, do you? There's no more verticals in your way. So you're back in kindergarten playing connect the dots. That's all we're doing here. We're going to connect. Oops. We're going to connect this dot to this dot. Come up here, go like that. Come back down, connect. Connect down here. Come back up, connect. Connect to here, right? Oops, I don't like that. Connect to here. And then from here, which way? Got to go up, right? No horizontals. No flattening. Can't go down. You'll cross the x-axis. Got to go up. There it is. There's the graph of that rational function. Beautiful. All right, let's graph it. Okay, so we have, oops. All right, let me get rid of all that. All right, we have x cubed minus 4x over x plus 7. Yeah, that was it right there. And we had a vertical at x equals -7. Okay, so this is what the computer gave us, right? So far, this is what the computer gave us, which is not, I mean, it looks like we have this kind of, let me see. I got to zoom out. Look, see, I'm zooming out. I still don't see anything else. Do you see that? What the heck? Oh, there it is. You see? You see, like, it's hard to see that part of the graph. Like, if you didn't zoom all the way out to 300, you would think, okay, there's my graph, right? I have to really like mess with this window to make it look like ours. See, I can do that, and then I can do this. Oops. That starts to look a little bit more like ours now, doesn't it? But now what you've lost is this in here. See, you don't really know what's going on in here. You can't see that little up and down thing as easily, right? Do y'all agree? You can see this part nice, but you can't see this part nice. That's why I'm saying there's pros and cons to this. This took longer, but I can tell you that the left side goes up and then turns up right here. And then we've got this little like wiggle that goes above, below, and back above. And that's just, again, it's just kind of hard to see that here, that little up down thing. So pros and cons, right? All right. Everything good? Understand? All right. I think y'all are ready. Everything I've done up to this point, I've kept everything very nice and clean intentionally because I just wanted to get the basic idea of how to do this down. This is more like what I want you to be able to do though. Okay. So let's start out. Let me go grab the steps. Yikes, right? Step one, factor everything. Well, the factoring up to this point has been straightforward, hasn't it? GCF, difference of squares. All right, well, how do we factor this? Well, let's start with the top. You know what? In fact, I'm going to go to a different page, because I know it's going to take me some work here. I'm going to go, let's just make sure we know how to factor this. All right, so factoring this. When I look at that, I realize I have 4 terms, so I can try grouping, right? I can try grouping, but I can also use the synthetic division thing, right? Do you all want to do that? Do you want to see if we can crank out the synthetic? Let's see if y'all remember how to do this. It's been a while. You take the number in the back, 12, you create a list of factors. You take the number in the front, 1, you create a list of factors. Because it's a 1, that's a good thing, right? Remember, if it was a 1 in front, then you only have, the list is only the list off of the 12. We don't have to worry about this. That sound familiar? I know it's been, yeah, spring break, yeah. All the factors of 12, 1 and 12, positive and negative 1, positive, negative 12, 2 and 6, and then 3 and 4. And that's it. And then you have to play that game where you put your numbers in here, 1, 3, negative 4, negative 12. And then start maybe with 1. I don't know. You want to start with 1? Let's see. I'm going through this. Let's see. 1 times 4, 0, 0. That didn't work. Okay, so I got to try it again. Try negative 1. That didn't work. All right. Two. Ah, 2 works. 2 works. Once I know that 2 works, I can rewrite this as x minus 2, and then the remaining 3 numbers will be the coefficients of the remaining polynomial, and the power on it will be 2 because the original thing I was trying to factor had a 3 on it. So this should just be x squared plus 5x plus 6. And this is a quadratic, and I'm hoping that you could factor that. If you can't factor that, you could continue with the synthetic division. All right. And I believe negative 2 would work on that. But I'm just going to go ahead and factor this. This becomes x plus 2 times x plus 3. So please understand that this step right here in blue, I'm trusting that you could factor that yourself. Are there questions? I should also mention to you that grouping would have worked here. For those of you who know how to do grouping, that would have worked. It probably would have been faster. But that's just the numerator, right? We still need to do the denominator. Okay, so let's go try and factor this one. I'm gonna go to that same page. First thing I want to do here is notice I have a GCF. I'm going to pull a GCF out, greatest common factor. Now, this will not, what's in the parentheses for those 4 terms will not go by grouping. Okay, you can try it yourself. The grouping will not work, which means what's in yellow here, I've got to do the same procedure with synthetic division. Why don't you do that yourself? I've got to blow my nose. I'm all congested. See if you can get all the factors. You only have to look at the factors of 75 because there's a 1 in front of the x cubed. Do all your factors of 75 and then try your synthetic division. And let's see. Let me know if you get it factored. I'll send the poll out. Let me know if you get to the point where it's factored. I'm gonna go blow my nose. I'll be back. I'm gonna start working it out while you're working on it, okay? So two of you say you have it. What number works?
-3.
-3? Okay, thank you.
Also, also I think -5.
Yeah, I'll probably be able to see that on the next step. I'm just gonna go another minute and just let people kind of catch up. Okay. So made our list of numbers. I didn't try these, but 1 and -1 won't work. 3 won't work, but -3 does. Once -3 works, that tells you that x plus 3 is a factor. These are the remaining coefficients, and you'll have x, be careful, it's x squared, not x to the third, because remember, we're working on the yellow piece only, right? The yellow piece only. So we should have an x squared here. And then when I got to this, I just did that mentally. I said, okay, I need two numbers that add up to be -10, but multiply to be 25. That's -5 and -5. So that's how that factors. Questions? So what is the complete factored version of this? It is, don't forget that x, it's an x and then x plus 3 and then x minus 5 times x minus 5 again, I'll say squared. Okay. All right. Step 1 is almost done. So here is the new, remember this was the numerator and now we have the other one is the denominator. So let me go back to this. The factored form of this is, should I already forgot? It's x plus 3 over x plus 2, x minus 2. That's what we got for the top one. Yeah, okay, and then this one was this right here. So x over, let's see, x, and then x plus 3, and then x minus 5 squared. That's what our original function is. Now, do we have any holes? Yes, we have holes here this time. We have one hole. See, there is a factor in the numerator that is common to a factor in the denominator. So those two will cancel, right? But this means that we have a hole at where? X equals where? So 3?
-3.
-3. It's what makes the factor 0. So it's the value of x that would create a 0 for both of those. So at -3. Okay. That's the first time we've had this happen, right, on a problem like this. So we'll have to keep that in mind when we draw the picture, right, that there's a hole there. And the good news is we no longer have to consider these factors. We can cancel them out. They're gone, but we have a hole at -3. Okay, that's it. Step 2. Let's move on. This is step 1. Step 2. Vertical asymptotes. Well, how many will I have? I need to set the denominator equal to 0. The denominator, what's left is this. So I get one answer here, x is 0. And from here, x is 5. So I have 2 vertical asymptotes. For step 3, I need the intercepts. I set the numerator equal to 0. But remember, I've canceled that x plus 3 factor. So I get 2 solutions here, -2, whoa, -2 and +2. Any questions? Fourth step, horizontal asymptote. Well, the degree of the numerator is 3, right? The degree of the denominator is 4. And so 3 is less than 4. So we're looking at case 1 here, right? So we know that we have the x-axis as our horizontal asymptote. Picture time. All right, let me start with my verticals. Well, you actually, yeah, let's start with the vertical. Let's just not forget about the hole, okay? Do not forget about the hole, all right? Verticals at 0 and at 5. Okay, so at 5, I can do that one pretty easily. Here's 5, boom, boom, boom. There's a vertical. And then I have another one at 0, which is the y-axis. So this is where I was telling you, I'll just draw your little dashes diagonally until you get up here, and then draw them diagonally so you can see them till you get down here. I have an x-intercept at 2 and at -2. I have a horizontal asymptote at the edges on the x-axis. All right. How many test points?
Is it 6?
How many verticals do you have? Was that
Oh, 5. Wait, no. I
Okay,
mean,
5.
verticals, there's 2, so you're gonna need like
2s.
5.
We'll need 5, exactly. Now you could do 6, but 5 is the minimum you need.
Hmm.
Okay.
I'm sorry.
So-
I also counted the horizontal asymptote.
Okay, yeah, just look at your verticals and your x-intercepts only.
Okay.
Okay, so I'm gonna pick something over here. How about -4? Sound good? something between here and here, -1, thank goodness, I don't have to worry about decimals. Here, 1. Here, something like 3. And over here, I don't know, 7, doesn't matter. And I've got to plug those in to my original function, but I'm going to plug them into the factored version. And I'm even going to cancel those factors, the x plus 3. So in other words, I'm going to be looking at this version of the function right here with that, with the x plus, oops, with the x plus 3 gone. Yeah. So watch what happens here. If we plug in a -4, -4 plus 2 is negative, times -4 minus 2 is still -6, over, don't forget this x right here, -4, times, and then look at this one, -4 minus 5 is -9, but then you're squaring it. And because you're squaring it, it becomes positive. On the top, 2 negatives become positive. On the bottom, a positive and a negative become negative. And a positive and a negative divided is negative. Let's try -1. If I do -1, -1 plus 2 is positive. -1 minus 2 is negative. -1 by itself is just negative. And then -1 take away 5 is, well, this doesn't matter. We're squaring it, right? No matter what, it's going to be positive. The bottom right-hand corner is always positive no matter what. So we get negative on top, negative on the bottom. That's positive. Oh, it switched again, didn't it? Negative, positive. Let's keep going. If you plug in 1, 1 plus 2 is 3. So I have a positive, and then I'm going to have 1 minus 2, it's negative. So I have a positive times a negative over, if I plug in 1 right here, I get positive. And then we already said the bottom right-hand corner is positive no matter what. So negative on top, positive on the bottom. The ratio of a negative divided by positive is negative. So it switched again, right? Let's go with 3. 3 on the top, 2 positives. On the bottom, 2 positives. Positive over positive is positive. So it switched again, right? Look at what happens at 7 though. At 7 on the top, they're both going to be positive. And when you plug in 7 here to the bottom left, you get positive, and then the bottom right is still positive. And do you see, you stay positive there? It didn't switch. So okay, let's do this. At -4, I have a negative number. At -1, I have a positive number. At +1, I have a negative number. At 3, I have a positive number. And at 7, I have a positive number. Any questions? Time to draw. Start with this point. To the left, I have the magnet this time. I've got to go get close to the x-axis. Over here to the right, I'm going to go through this point up to this point. When I get through these points and get to here, now I've got the barrier. The vertical barrier is going to send me up, right? Again, can't turn down, I'll create an x-intercept. So got to go up here. Then I come over here and go to this point to the left. It's going to have to go down, connect the dots, and then it's going to go up because of the vertical. So it's going to look something like this. And then at this point to the left, I've got to go up, and to the right, I've got to flatten out, get pulled to the magnet. Okay, it's almost correct. It's almost correct. There's one thing wrong with my picture. What's wrong? Yeah, Javier. We have a hole, right? We're supposed to have a hole. Don't forget that hole. Where was the hole? At -3. So the way I'm going to do this is I'm going to go over here, right here at -3. Here's -3. My graph should have a hole right there, right? So what I'm going to do is I'm going to erase this. I'm going to put a hole here and then have my graph go like that. There it is. I'm going to graph this. Let me do it on a different page first. Let's see here. So the top was yeah. Okay. Here's what the computer is going to show you. There it is. Let me go to a standard picture here. There's the standard picture from the computer right there. All right. Now compare this to our picture. Let me move this stuff out of here. Whoa. All right, so I know that's hard to see. I've got quite a bit, made that pretty small, but let's see. You can kind of see that we both have this behavior here, right? This kind of like volcano effect where both things are going up there. We've got that. I think you can agree we've both have the flattening out on the edges, right? We got that. We also have this kind of up on the left, down on the right. We've got that there. Yeah, I think it's pretty clear we both have an x-intercept at 2, right? A little harder to see that this is an x-intercept here. I mean, it's hard to see what's going on here, but the graph on the computer, for sure, what we don't see is a hole. You see that at -3? There's no hole here. Doesn't matter how far I zoom in, the computer's never going to show me the hole. Now, if I try and go to it, see, it'll tell me it's undefined at -3, but it doesn't show me it. It shows me a solid dot there until I get to -3, and then it shows me a hole. That's really weird. Why is it doing that? That's really strange. There, yeah. Okay. That's a really good problem because it pulls a lot of ideas together, right? You got to be able to do your synthetic division and all that stuff. So, all right. Let me see. So this is the review that I'm going to send out for the exam on Monday. And I'm going to have to add some stuff to this. Okay, I'm going to have to add some stuff to this because what we're going to cover next time will be on the test. But you don't have to freak out about it because it's not brand new material. It's just using what we already know to answer some other questions. So why don't we do this? We've got a good half hour left. Why don't you see if you can do number 6? Okay, number 6 is, yeah, it should take you a little bit of time. All right, I want you to go through all the steps and see if you can graph this function. Do y'all want breakout rooms or you just want to stay working on your own? I don't care, whatever y'all want to do. I'll do breakout rooms, and if you want to talk to each other, you can help each other out, whatever. Check your answers with each other, that's great. And why don't you do this? When your group is, if you finish the graph, go back to the main session, okay? Take a minute to copy the problem down, because once you go into the breakout room, you won't be able to see the problem anymore. There's going to be about three or four of you in each room. What I recommend is if you go in there, just check with each other. Hey, what did you get for, the factoring, or, just talk to each other. Good luck. Alyssa, did you all come up with something?
I think so. I did it right. I think I did it right.
Okay, I'm gonna share my screen. You can take a look at it and see if it looks like what you got. Okay, I think everybody's back in here now. So I put up the graph of the final graph of the function. I don't show all of the work here, but at least show like what the partial or what the synthetic division gives us and test points, what you should get for each one, and then, you know, the final picture here. So here's what I'd like for you to do. We still have 12 minutes, but I'm going to send out the solutions to the review later, not yet. What I'd like for you to do tonight for homework is to work on the first, well, you just did problem 6, so work on these 5 problems. And I'm going to send this to you all. You know how I send out the notes into that folder? You can get the notes from the class. I'm going to just send this out, put that in there, and then you can go back and pull these up later. In fact, I can do that right now. Let me just do it. Where's my little thing? There we go. Okay, so that's now posted in our notes. You can go get that. And that's all I want you to do to work on, you know, for homework. And if you have questions, we can talk about questions you might have over this on Wednesday. All right. Any questions? Okay. All right. Very good. See how that goes, and I will see you on Wednesday. Everyone have a good day. Stay safe. I guess the weather's supposed to get bad later or something, right?
You too, Professor.
All right.
You too. Thank you. Have a good day.
You as well.
Bye.
Professor, can you go back to your solution to the
Yes.
problem?
Yep.
So, quick question. I was looking at the syllabus, but I didn't know if we were like behind or anything. It's the test would be, is it Wednesday or is it next Monday?
I thought it was Monday.
Yeah, I think I saw Monday. I just couldn't remember if we were behind on any days or if we were back up or what.
Yeah, it's Monday.
Perfect.
It's
Yeah, I
Monday.
just want to write that down so I remember.
Yep. Okay.
Thank you. Have a good
Yep.
one.
You as well. All right. Here's
Yeah,
the
'cause I used, it worked with -1 unless I did my math wrong. But I got the x for the numerator x times x plus 3, and then my denominator was x plus 1, x minus 5, and then x plus 3.
Okay. Check your synthetic division. Did you have in the box 1, 3, -13, -15?
Yes, sir. And I used -1.
-1. Yeah, -1 should have worked. Okay, so let's do that. If you had done -1, 1, 3, -13, -15, you get 1, -1, that's 2, -2, that's -15. Then you get +15, then 0. Okay, then that should break down to be x plus 1. And then this should be x squared plus 2x minus 15. And then when you factored that, did you do +3?
Oh, I know what
Sorry,
I did.
+5?
I didn't.
I think that's where. +5
Yeah, I
minus-
didn't put +2. I put -2 by accident.
Gotcha.
Okay, never mind then.
Okay, yeah, that's it. You saying you had a negative right there on that too?
Yeah, instead of
Yeah,
+2, I had -2.
Then that would have changed the factoring. Yeah.
Yeah.
Okay,
Okay, thank you.
yep, no problem.
Great. And the homework's 5.3 and 5.4 that it show that it's due tomorrow. Do we
Yeah,
still
I'm
do
gonna go
that?
change that. That's not gonna be due now.
Oh, okay, okay, thank you.
Just do the review,
Okay.
okay? All right, thank you, Caitlin. Have a good one.